welcome back. In this video, we're going to go over an exercise where we will be given two rates that are related. So at this moment, I want to step back and explain the situation here. So we have two different variables, x and y, and normally y is a function of x, but in certain physics problems, both x variable and y variable may depend on another third variable, and that could be time in general. This is, for example, you have a moving object in the air that moves both in x direction and y direction and in time. So the rate of change of x with respect to time, or rate of change of y with respect to time can be searched for. So in this particular problem, we're given an equation in the implicit form, x times y equals 4, and we are asked to find dy over dt when x equals 8, and dx over dt is given in the problem as 10. You just want to make sure that when we take the derivative of both sides of the equation, which is the implicit differentiation, we want to make sure that we take the derivative not with respect to x, but with respect to the third variable t, which is time. In other words, let me just write that precisely here. So the derivative of this equation is xy prime equals 4 prime. Let me just write that precisely here. So this is going to be the derivative of x times y, and that's equal to the derivative of 4, which is the derivative of the constant, that is equal to 0. All right, when we took the derivatives of both sides of the equation, which is the implicit differentiation, we put a prime here, we put a prime here, but make sure that you are aware of what prime means here. It's in fact the derivative with respect to time. So like here, when I say dy over dt here, what I mean by that is just y prime, but that prime denotes the time differentiation, and same here. So dx over dt, this is, you can call it like x prime, but we know that x prime is the time derivative of x, so that's why you shouldn't be confused here. So when we say x prime here, we're not taking the derivative with respect to x, but with respect to time, so we keep it as is. So this is in fact dx over dt, and this y prime term is dy over dt. So the goal here for the first problem is to find dy over dt when x equals 8, and as well dx over dt is given as 10. So why don't we just plug in the given values here. So dx over dt, which is this guy here, okay, is 10, and x equals 8. And we're supposed to find y prime, but we need y. So how do we find y for this x here? So all we're going to do is just plug it back here in the function expression to find the y coordinate of the point. So if x equals 8, 8 times y equals 4. So let me just write it here. For this problem, y is nothing but 1/2. Okay? So y is 1/2 here. All right, so once we crunch those numbers, so 10 times 1/2 is 5, and this is equal to 8y prime. So 8y prime is equal to -5, and y prime turns out to be -5 over 8. Right? So this takes care of part A. Part B is the same deal, but this time x equals 1. But dx over dt is provided to us. And now we have exactly the same differentiation, implicit differentiation, spitting out this equation here. So first, let's find what the y coordinate corresponds to x equals 1. Well, when x equals 1, that's just y equals 4. So here, y equals 4. All right, so this time dy over dt is provided to us as, in other words, y prime is provided to us, that's -6. And also y equals 4, and x equals 1, and we're going to solve this for x prime or dx over dt. So dx over dt or x prime. Okay, x prime is sort of like the abusive notation, but as long as you know what you're doing here, you're safe. So x prime is going to be -6 divided by 4. So in other words, -3/2 is the answer for dx over dt being asked in this question. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.